Yes.
Okay,
Thank you. Now I can.
no
Okay.
problem.
So can you show me the problems that you have solved so far?
Okay, let's open the.
So for now, you want to start with weekly sessions of 1 hour. Is that it?
Probably sometimes 1 hour, sometimes 2 hour. How about
Okay.
that?
Yeah,
Mm,
yeah, of course. I mean, whatever you want.
mm. Yeah, and I also have a document. I every time I solve a problem, I would add to this document, and yeah, there's um some questions I encountered before, and even how I solved that problem. So it's just much easier for me to review. Yeah, to just to see what the problems I had before. Just that, yeah, that's all of the things in here. Mm.
Oh, I see. Yeah, I think why don't you put that on GitHub?
For this one, yeah, sure.
Yeah, I think it's better to put it on GitHub. Well, like that, I mean, other people can see it, and even the interviewer, they can see
Mm,
your solutions, and they can see also how organized you can be, or like how you can structure a project, stuff like that. They can have a look at the code, and
mm.
also it gives you, some moral boost, especially when you solve a problem each time. I mean, you're gonna get that green square on the GitHub thing, and that's pretty good to have.
Green square. Okay. What is green square?
Yeah, I mean the when you go to GitHub on the
Mm.
bottom, I don't know what is it called exactly, but on your profile you can see each day is marked as a square, and it becomes
Oh,
green. Did I say
oh.
red? Yeah, it becomes green when you
Mm,
make an activity like push, or yeah, the contributions. Yeah, that's what I mean.
okay, got you. Mm. Uh,
Yeah, okay. First of all, do you have any questions? Is there something about one of the problems that you have solved that you want to discuss?
uh, no question. I feel. Mm, I just solving this problem right now. Is I just solving some linked list problems, but no question. I just try to see their discussion and try to solve the problem. So I don't know what's the question I will have. I think um you can decide what we discuss discuss actually.
Mhm. Okay.
Mm,
Okay. There's one problem that I'd like you to have a look at. Okay.
okay.
Can you sort, can you pick only easy problems? Filter by easy?
Yeah, let's try.
Yeah. Yeah.
Uh,
Sure. And then sort
I'm
by acceptance rate.
so sorry, see again.
I said, can you filter, only choose easy problems, and then filter, like sort by acceptance rate?
Acceptance free.
Okay, first, can I have control?
Oh yeah. What's that? Wait a minute, seconds.
Okay, is it
Oh, you can control my.
really?
I don't
Uh,
know this function.
Oh, yeah, it's working.
Okay.
So yeah, easy, and then we sort by acceptance.
Most are easy problems. Some medium problems almost have no difficult problems. So
You mean these problems are very easy for you to solve?
no, I don't know. I'm not sure if I can solve this problem. I just said I solved most the problems I already done are easy problems.
Okay.
Mm.
Purchase ugly pairs.
What's your time right now?
It's 10:52 p.m.
Wow.
Yeah, it's a bit late.
Yeah. You have daytime job, right?
No, I'm a full-time freelancer for now.
Okay.
Okay. Can you read and solve this one? Okay, I'll give you 10 minutes to solve this one.
Okay, let's see.
Yeah, hold on.
Okay.
Let's timer. Oh, sorry.
Let's
Okay.
running some give up a read knobs. See.
I'll be right back in 1 to 2 minutes.
Mm. Okay, let's see. Right. Okay.
Okay, I'm back.
Mm. I don't know. I use Swift function. It's called enumerated. So
Yeah,
I
it's
can.
fine. Yeah. Yeah, did you submit? Or you just run the code, right?
Let's see. Submit. Wow.
Okay, nice. What are the complexities? Time or memory?
Time and memory. Let's see. Time is ON and space is O1, I think.
Okay, why is it O and time complexity, and why is it O of 1 memory complexity?
Because I iterate all of the elements in the array. So if I have n elements, I just iterate n times. So that's why I count this O(n) time. And the space is, I just use a variable to storage the sum value in every time of the iteration. So I think this O1.
Yeah. If we do not count the nums array, then yeah, it's a O of 1 memory. Okay, what about this problem? So you have Q queries to answer.
Q queries to answer.
And an array of n elements.
Q queries to an
Yeah,
array.
for each query, you have I and J as input, and you need to answer sum of an array A and elements AI till a J minus 1. Example. Did you understand the problem?
You can write the example. Probably I can understand.
Okay, let's just take this as an example. So this is the array A. And then you have query Q1. It says you have 1, 2. So this is I and J. You have to answer. The sum is 3. For Q2, you have, let's say, 1 to 4. You have to sum 1 plus 2 plus 3 plus 4. This is what it says, I to J.
I see.
Or you know what? Let's make it J like this. So the sum of 1 to 4 of elements from index 1 to index 4 is 10 here.
Okay.
Well, I've written the output here, but it should be here. So the input like this. And the output 3, and 10. We can add another one. Q3, 1 to 3.
Yeah,
Well,
I think I got your point.
okay, cool. So 2 to 3 is 2 plus 3, which is fine.
Okay. So I just modify the same based on those code. Could I do that?
Yeah, sure.
Okay. IG. Let's see. Is index. Yeah, it's let's see if I equal to 1. Index. No. Yeah, I think that's it. I just added 2 lines in here.
Okay, so now you're answering one query.
Query 1, you mean?
Here, I mean, you're answering one query, right?
Yeah.
Okay. What's the memory complexity and time complexity?
The time is still on. Space is still O1.
Yeah, that's right. Okay, but the problem says that you have Q queries, not just one query. Here you have made a solution for only one query. So can you adjust the problem and make it answer Q queries? So you have A, I, and J, and you have also Q, which is the number of queries.
You mean the queries being storage in like an array? So every time I just pick one.
Yes, you can consider it as an array, something like this.
I see. Okay, got your point. Queries. And I have Okay. Do you think it's correct?
Item. Okay, what is the complexity now?
Um, the space complexity is still ON.
Mhm.
Yeah,
Space?
ON. Space
Why
is
ON?
because it's actually it's let's see. It's O squared too. Let's see how to say let's search
Memory or time complexity?
a time is
Oh, okay.
n squared too.
You mean n squared?
N squared, yeah.
Okay, what about memory?
It's O1.
Okay, that's right. But can you make this better? Can you make it faster? So the complexity is actually it's not exactly n squared, but it's q times n, because q is the number of queries and n is the number of elements, right?
Yeah. You mean make this function much faster?
Yeah, this part, can you optimize it and make it faster?
Let me think about.
Have you heard of cumulative sum?
No. What's that?
Okay, cumulative sum is a very useful trick. Okay, here, for example, you see this?
Can you say again the name? What song?
It's called cumulative sum.
Cumulative sum.
Yes.
You mean like a storage the sum value every time?
It's using this array. This is the array that you can use to extract the answer. So let's say that no. Let's say that I is there and J is here. So for the first query, it says 1 to 2. Okay, when you have I and J here, the answer is 3, right?
Yeah.
Okay. If you do, let's say that this array name is CS, and CS is for cumulative sum, okay? So CS of J minus CS of I minus 1. What is the value here?
Three.
3, and that's the answer, right?
Mm.
Okay. What about this? So the second one, 1 to 4. So 1 to 10. When we do CS of J minus CS of I minus 1.
It's 10.
And it's the answer, right?
Mm.
Okay. So cumulative sum, this array is, it has this formula. CS of I is the sum of from AI from A0, sorry.
I know what you mean. It's just like
Yeah.
I allocated a new like array or to storage the sum value every time.
Yes. And so when you have CS of I is the sum from 0 to I, and you do CS of J minus CS of I, you will get the sum from CS of I to CS of J, because CS of J, sorry, I minus 1. CS of J is the sum of A to 0 to a J. There's a part that will be removed because you have A0 plus A1, you know. When you do this part from minus this part, there is a certain part, because at a certain point, there is AI minus 1, like this, and then plus AI plus AJ. So only this part will stay, because this part is going to be removed. You understand?
Yeah.
Yeah, CI minus 1. Or is it? Yeah, CI. This is a very useful trick. So when you use this, what is the complexity that you will have when you use this array and this trick?
Let's see. The time complexity is still n squared. O n squared.
No, it's not.
No?
No.
Let's see. Time.
Okay, hold on. For when we build this array, let's say that we have one query, only one query. Let's say per query, what is the time complexity? So when we do this operation, what is the time complexity of this operation?
On?
No, only this operation. We only have one operation. This is O1.
It's O1. Okay.
So with this trick, with cumulative sum, we can answer sum of AI till aj in O of 1. Is it clear?
Yeah.
Yeah, so
Mm.
now we can answer Q queries in O of Q times O of 1.
Let's see.
Let me know if something is not clear.
No, yeah, go ahead.
No, is it clear?
Yeah, clear.
Okay. Now I want you to implement this cumulative sum solution.
I think the space and the time complexity is ON.
It's ON.
Mm.
It's actually not ON, but it's exactly, it's max of ON OQ.
ON OQ.
Yeah. Okay.
What is Q? Q queries.
Q is the number of queries. The reason why I say it, or you can say simply N plus Q. I mean, we don't need the max because we are literally going to be using N plus.
Oh, I understand why.
Yeah. First, you have to build the array, and you build it in O of N, and then you do Q queries.
Yeah.
And when you do Q queries, it's Q times O of 1. So Q, the total is O of N plus Q.
Okay. But why we said is max ON and OQ?
Because it's linear. It doesn't matter. I mean, it's more correct to say it this way, O of N plus Q, because it's a sum. Because first, because this is simply linear, you know, but it doesn't matter. This is more correct. It's better to say it this way.
Which one is the correct answer? If they ask me the time complexity, what should I say? Is N plus Q or max Q N Q?
The other one is not wrong, but this is more correct because here you can show that you are doing N queries and then you are doing Q queries because this is linear, you know, and this is linear, and O max of ON OQ is still linear, but this is better, you know, because as I said, because you have to implement the CS array, cumulative sum array in O of N, and then you answer Q queries. But the whole thing is still linear. Yeah.
Yeah. Okay, I got you.
Okay, can you implement that?
Let's try. See. Yeah, I think I just add this number to an array and output this array.
Sorry.
Yeah, that's it.
Mm,
I don't know how to. Do you know how to like in the index and all of the things like any. I can use any key to make a little bit.
this part is correct. This part.
Okay.
Okay, and here that doesn't matter. You can print or, I mean, I didn't specify. You can either print it or add it to an array. But here, this is not correct.
Not correct. Let's see.
Mhm. You don't need I and J here.
I don't need. You mean I can remove this part?
Yeah.
Think so.
Okay. Do you understand?
Yeah. Do you know how to make this part? Is just make the all
Oh,
on the
yeah.
left.
Shift tab.
Shift and what?
Tab.
And
Shift tab.
shift tab.
Tab. Shift plus tab.
Okay, let's try. Okay. Good.
Okay. Okay, nice.
Good.
Okay. So since this is our first session, we will start with, some quick and easy problems. And then when I get to know your level more, we will be adjusting the problems more. So don't worry. I mean, I'm not going to give you easy problems. And whenever some problems are easy for you, I will push you, to your limits, and we will try to learn something new every time. So even with this one, the problem is easy. I know that it's easy, and you have solved it in maybe 5 minutes. But
mm,
we have learned a new trick, which is the cumulative sum, which is something that's very, very essential
mm,
to solve a lot of problems. Some of them related to arrays, even related to matrices sometimes, and to
mm,
dynamic programming problems. So this
mm,
is a must-know trick, you know.
mm.
Yeah, I gave you another problem. It's another easy problem. I send it on the chat, on the Zoom chat.
Let's see.
Did you solve this one before?
No, no.
Okay. We forgot about the timer. Okay, but you have done well, so you have solved it very fast. Okay, for this one, I want you to solve it in, let's say, 5 minutes to solve the easiest version. Okay, you can start reading.
Okay, let's try. A number.
Jing, can you start, letting me what you are thinking about? So try to
Oh,
code and speak out loud so I can know what you're thinking, okay?
okay. So I'm thinking about if I can sort it this array. So the index of every element should be um um let's see that would be the uh the value should be how many elements less than the current element.
Mm-hmm.
So I just use the index as the result and storage the index into the array and return this array.
Okay,
Mm,
cool.
mm. I'll take.
I've got a question,
Mm,
Jing. Why
yeah.
did you go with this solution? Didn't you find a solution that's easier to implement or like kind of faster also to implement?
I only came out this solution actually.
Okay. Uh,
Mm.
you know brute force, right?
What was it again? Gruso?
Brute force.
A brute force, yes.
Okay. What do you think do you think there's a way to solve this using a brute force solution?
Um, do you think this is brute force solution? I think this solution actually like a brute force.
Mm,
Mm.
not actually. Well, there is a more straightforward solution to implement that. That's more of a brute force than this one.
Oh, really? Mm. brute force. I think the brute force, I think I will just iterate every element and to account the number
Mm-hmm.
every iteration.
Yeah.
Yeah, that's different with current solution, I think.
Yes. And does it work, the brute force solution?
It should be work, but just use more time.
Uh, yeah. And is it a problem that it
Mm,
uses more time?
I think they use more time.
Yes, but that's maybe that's not an issue to use more time. Did you check your constraints, for example? Did you check the length of the array here? Maybe, you can have a high complexity, but the numbers are small. For example, look, if let's
Mm,
say you have a solution that's O of n to the 3, but
mm,
n goes up to 10 only. So 10 to the 3 is 1000.
mm,
This is very fast. So
yeah.
you need to check your constraints. Your constraints here.
Oh, I didn't notice that. Is
Yeah, you should be always checking the constraints before coding your solution.
okay. I never noticed that constraints before actually.
Yeah, well, the thing is that this is important because
Uh,
your solution here, it's correct. The idea is correct, but it's kind of harder to implement. There is a way that's way faster to implement.
mm,
That's the brute force, and it will pass also. It will get you accepted,
mm,
right? Okay.
mm.
Can you okay, look, can you implement it? Just let's comment this one and we will get back to this one later. But can you do the brute force one?
Let's try. Let's try.
Okay.
Mm.
Okay, please try to describe what you're doing.
Um. So in the first iteration, in the first loop, inside I just iterate every elements in the array, and in the second loop, I gonna to calculate the numbers of elements that less than the current element.
Okay, got it.
Mm.
So try to make that a habit. Whenever you work, especially in a real coding interview, try to explain what you are doing. Okay?
Okay. Okay.
Yeah. So that you make it a habit and you do it naturally.
Okay. You mean I explain first, then if we all agree with the solution, I can begin writing the code.
Yeah, yeah. And even when you are writing the code, it's better, to explain. It's always better to explain your thought process, even if you're just thinking, just let the interviewer know what you are thinking about. And when you're coding, also,
Mm,
explain your thought process and speak out loud about what you're doing and stuff.
okay, okay. Uh, okay. I think that is the brute force.
Okay, can you run the code?
Oh, run the code. Let's see. Results notes. Oh. Pen. Oh, wrong. Let's see. This question. Oh, this now. This one.
Jing, look at where your algorithm is getting you incorrect answer. You're getting incorrect answer here, here, and here. I mean here. Also, see, it should be 113, not 000.
Yeah, I saw it. So I think that must be some problem inside the algorithm.
Yeah. So
Uh,
for 2, it should reach the 1. It should iterate here and
uh,
then iterate the second time. When it reaches 2, your second loop has to iterate over the whole array, and it should find 1 and
mm,
increase 1 there.
uh, I think it should be.
Yeah, exactly.
Mm.
That's a problem.
Oh, correct. Okay,
Yep.
okay. See.
Okay, nice.
Mm.
So sorry, I'll just go to the timer. Okay, so 19 minutes, but let's remove 5 minutes. Let's say that you have just you went for this solution. So let's do 15 minutes for the brute solution. Okay, what is the complexity? Complexity
Mhm.
and memory complexity.
Um, and the time complexity is n squared, and the memory complexity is O n.
Why? Why is it Owen?
Um, because I think I storage like let's see, calculate. Because I think I storage like an elements as a result, so it should be O(n).
Yeah, that's right. But sometimes the thing is that sometimes the output array is not counted in the memory complexity because you have to build it anyway. You cannot go less than O of n because the output is already O of n. So yeah, just try to mention to the interviewer that okay, so the output is O of n. We cannot go less than O n, but the extra memory that we use is literally O of 1. It's 0. You don't create any memory apart from the output array. Yeah, just give the interviewer a sense that, you know, make him understand or her understand that that it's O of n that because it comes from the output array. And
Mm,
also, if you ignore the output array, it's going to become another complexity, which is here O of 1.
makes sense.
Okay,
Yeah,
but mhm.
actually, you see the last solution I provided, I think it should not be O(n).
Yeah,
Is
yes, I was gonna ask you what are the complexities of this function? Okay, so let's just write for the brute force is of n. It's let's say just of 1 because we don't need any memory apart from the output array.
why is is O(1)? Is O(n) and O(1) is same thing?
No, just okay. If you want to do the O of n, I'm just saying that it's O of n if you count the output array. Otherwise, it's just O of 1.
If count the output array. Okay, so it's depend on if I have output.
Yeah, well, here you do have output.
Mm.
Okay. So what are the complexities for this one, this solution, not the brute force?
The time complexity is O(n).
Oh, and okay. And
And
what?
in the space complexity is the it's also O(n). Or because I don't know if 2n and n is if it's the same thing, but I think it's like it's 2n.
So, sorry, it's what?
It's 2 O to N.
Yeah, so it's of n linear, you mean?
Mm-mm.
Okay,
So
is this
it's
the
O.
memory?
Yeah.
Why is that?
Because here I use a uh use a dictionary to storage the index. It should be ON. And here I also use results to storage the index.
Oh, I
So it,
see. That's right. That's right. Okay. Now let's go back to this sort thing. Do the time complexity, sorry. You said that it's O of n, right?
mm,
Why is it O of n?
you mean the time
Yeah,
complexity?
yes, the time complexity. Why is it O of n?
Uh, because it's the same thing. In this iteration is ON, and here is ON, so it's O to N, but O to N is same as ON, right?
Yes, but you have forgotten something, the sort.
Oh yeah, I forgot it. um, sorry, but I don't know what is time complexity of sorted function, because it's a Swift provided function.
Yeah, it's usually
It's an
it's
n-log n.
yeah, exactly. And also, you forgot about the dictionary. You need to know the complexities of the dictionary access. I'm not sure, to be honest, because I don't know Swift, but in dictionaries there are maps or hash tables. The hash table is of one, and there are maps like in C++ that are implemented as red black trees, and the one operation is log n. So when you do n operations, it's going to become n log n.
Ah,
Yeah, I'm just saying that you need to pay attention. So for dictionary, if it's a hash table, then one operation is O of one. If it's a red black tree, red black tree, then one operation is O of log n. So you can read quickly on red black tree. This is red black tree. I don't know the implementation in. So yeah, this is the space, and those are the operations.
okay.
And the hash table. Hash table is this. You see the complexities. Well, I mean the average. Here the worst case, if the if you know the hash function and you can somehow like hack the hash table into putting all the elements into one cell, then it becomes O of n. But this case is unlikely to happen, you know, but it can happen. This can happen. Okay. But usually when we talk about hash tables um in coding reviews, it's usually O of one. But when you understand how it functions from the inside, because there's a hashing function, you know, and a hashing function can be reversed. So it's a mathematical, you know, formula, because each value is mapped. Like for example, John Smith is mapped here 2, and Lisa Smith is mapped here 1. But there are other values that also can be mapped with 1 and 2, you know. If the guy, or the people who create the test cases, if they know the hash function, then they can give you some test cases where all the cells, only one cell will be used. They will be stacked under only one bucket. This is a bucket,
Mm,
and it's gonna become O of n. We can, if you want, we can discuss it another time, but this is not very important for now. Just for now.
yeah.
Yeah, but for you, it's important to know that it's important to pay attention to the implementations, because, as I said, it's either we can look for it, like dict. Oh, sorry, dict.
Let me see. Okay.
Okay, yeah, dict in Swift implementation, or complexity, something like that.
Mm. Oh, one. Or actually, I can intended choose
Yeah, you
a
see,
good data structure.
so it's a hash table
Oh,
assuming maximal hash collisions. But as I said, those are some details that you should know, but we can discuss them another time. This is
okay.
this is the dictionary, right?
Mm.
Okay, so this is yeah, this is not logarithmic type. It says that it's O on one, so it's a
Mm.
hash table, which is great.
Yeah.
Okay. So the time complexity is not O of n, it's O of n log n.
Mm.
Okay.
Mm.
But there is a sort algorithm that is O of n, and that we can use here. Do you know that the sorting algorithm?
You mean ON?
Yeah, there is a sort algorithm that's O of n.
Uh, a quick, like not quick.
Quicksort is n log n.
Um, bubble sort.
Bubble sort is n squared.
Mm, I don't know which one is ON.
Have you heard of count sort?
Comfort. No, I forgot this one.
Yeah, it's linear.
Ah,
Count sort is very, very, very easy.
okay.
Do you know a frequency array?
Sorry, say again your question.
I said frequency array.
Frequency array. No.
Okay, no problem. We will go over these topics. No worries. Okay, so let's say that we want to sort this using count sort.
Mm.
What count sort does is, like, this is, let's say, original array count array. It starts like this: 0, 1. Okay, but I'm gonna do index here. 0, 1, 2. No. 3, 4, 5, 6, 7, 8. Okay, so the count array, it goes over the original array. So it first encounters 8. Sorry, this is 0. When it finds 8, it goes to this array, to the index. So it goes to count of this value, and it counts. So it's gonna, what count means, it's like a frequency array. Whenever it finds that value, it's gonna do plus plus to that value, and it's gonna increase it to 1.
Okay.
Okay.
Oh, okay.
Yeah, then it goes here. And I'll create the usual. And it goes to 1. For 1, it comes to this cell and increases the number. It goes to 2 here. 2. This is 2 because it's this one. And then it goes to. Sorry, I think this is confusing. It's better to put it.
It's you're like a function of dictionary. It's just the value for storing the numbers of that element in the array. Right?
Yeah.
I feel it's like
Yeah, just let me finish and we can probably discuss it. Okay, and then you go over here, the second 2. It was 1, sorry, so it was like this, 0. And then when we went over this cell, it becomes 1, okay? And then we encounter another 2, so we increase this value. We have 2. And then we have 3. We come to this cell and we increase by 1. So here we can construct sorted array. We can construct the sorted array from the count array. And this is done by the following. For example, so this is element number 0. How many zeros do we have?
0.
0. Okay, so there's no elements. And then this is the cell number 1. How many ones do we have?
1.
Okay, we write 1. And then we go to 2. How many 2's do we have?
2.
Exactly. So we have 2 2's. We write 2 2's. Okay. Then how many 3's do we have? Because this is cell. This is 3. You see? You look at the index. This is the frequency. So you see, come here. This means that we have only 1 3. 1 of the index. Okay. You write 3. And then you come here. This is cell 4. We have 0 4's, 0 5's, 0 6's, 0 7's, and only 1 8. So we write 1 8. Look at this array. Is it? You see, it's sorted.
Yeah, it's a smart way, I think.
Sorry?
I said, I feel it's like a smart way to sort.
Yeah, it is. And it's pretty simple. And it's just a count array,
Yeah.
You only go over the array and you increase the frequency. That's it. Okay. So you can have the original array and you can do create the count sort, like the sorted array. From here, you can construct the answer. And your answer will be, the complexity will be O of n instead of O of n log n.
Yeah.
Yeah, and more precisely, it's gonna be O of, okay, but by the way, we need to precise that the count sort doesn't always work. It only works when you have a small range of elements, because you have to look here. Your numbers go from 0 to 100. This is a very small range of elements. But if this was, let's say 10 to the 9, the count array would be huge.
Yeah.
And we cannot do that. Okay?
Okay, so it's depend on the constraints. If the
Of course.
number of the elements is not so much, we can choose.
Yeah. The range has to be small enough.
Okay.
Okay?
Good.
Because the complexity is, it's called linear, but exactly. It's O of, as we can see, what it's, I'm clicking, but it's not working. I don't know why. Anyway, so it's O of n plus k, where k is the range of the non-negative key values.
I see.
See? So k is the range and n is the number of elements. Because you have to go over both. You have to go over the elements and you have to go over the range. That's why it's O of n plus k.
Okay, Dia, you know what? My computer is almost out of battery, and I don't know why I cannot charge right now.
No
So,
problem.
but only have 2% of the
Oh, okay.
battery. Let me
Let me,
try. 7 seconds. Let me try.
yeah, sure. I paused the session.
No, can charge. I think probably my charge line has some problem.
Do you have to go?
Yeah, because my computer out of battery right now.
Oh, okay. No problem.
I think we can end up at this time today.
Sure. Yeah, no problem.
Okay.
Then yeah, I have some feedback. I'll write it down for you so that you can read it since you don't have time.
Okay.
Okay.
Thank you so much. It's a good class.
Yeah, super welcome, Jing. It was awesome to work with you.
Okay. Okay, let's talk later.
Yeah, sure. Thank you, Jing.
Okay, bye-bye.
Bye.